A little-known French startup just handed AI engineers something that could fundamentally change how the entire industry deploys code on chips. ZML released a free tool that speeds up inference. That's the technical process where an AI model actually runs and produces answers across basically every major chip type on the market. Here's the shocking part. They're not asking for money, not locking it behind licenses, just giving it away completely. It works with Nvidia GPUs, AMD chips, Intel processors, and even custom silicon from companies like Google and Apple. Think of it like this. Imagine if someone handed car manufacturers a free universal transmission that worked in every type of vehicle, made them all faster, and said use it, modify it, build on it. That's what's happening in AI right now. The inference speed problem has been a hidden tax on every AI deployment. Models run slower than they should. Companies burn through electricity and cloud costs just to get reasonable response times, and end users wait longer for answers. ZML's free tool directly attacks this inefficiency by recompiling how code runs at the chip level. And here's the thing that changes everything. It's not a proprietary black box. It's built with open standards that any company can integrate into their own pipelines and customize. Before we go deeper, you need to understand why this matters right now. ZML is a French AI infrastructure company that's been quietly building optimization tools for years, but they've just decided to open source their crown jewel. Inference has become the silent killer of AI economics. See, everyone talks about training. That's the expensive upfront process where you teach an AI model. But inference is what happens billions of times a day. Customers asking ChatGPT questions, businesses running AI locally, devices processing voice commands. All of that is inference. And it's been running on software written decades ago that was never designed for modern AI workloads. The problem compounds at scale. If you're running a chatbot that answers 50,000 questions per second, even a tiny efficiency loss multiplies into massive energy bills and slower responses. Companies like OpenAI, Google, and Meta spend hundreds of millions annually just on inference infrastructure. They've had to hire armies of engineers to optimize performance on specific chips, custom code for Nvidia, different code for AMD, yet another version for Intel. It's a nightmare. ZML's insight was brilliant. Why not create one universal optimization layer that works everywhere? Instead of each company reinventing the wheel, they built something that automatically compiles AI workloads more efficiently regardless of the underlying hardware. And by releasing it open source, they've unified the entire industry around a common standard. This is where it gets interesting. Here's the technical magic. When an AI model runs inference, it's essentially executing billions of tiny mathematical operations, matrix multiplications, tensor transformations, activation functions. The challenge is that chips are different. Nvidia's GPUs have a certain memory architecture and parallel processing structure. AMD's chips work differently. Intel's processors have different cache hierarchies and instruction sets. Traditional AI software compiles differently for each platform, and nobody really optimizes across all of them equally. ZML's tool works like a translator. It takes the AI model code and analyzes the underlying computational graph, essentially the blueprint of what operations need to happen and in what order. Then it intelligently restructures that graph to maximize performance on whatever hardware it detects. It might batch operations differently, reorder computations to fit better in cache, or parallelize work in ways that exploit each chip's specific strengths. The open-source nature means the entire community can contribute optimizations. Someone finds a clever way to speed up vision models on AMD. They push it to the repository. Another developer optimizes language models on Intel, merged in. The whole ecosystem gets better continuously. What makes this truly revolutionary is the performance gains they are reporting. Studies show inference speedups between 20% and 200% depending on the model and hardware. For a company running AI at planetary scale, that's not just efficiency, that's transformational cost savings. But wait, there's something nobody's talking about. Let's ground this in reality. Imagine you're running a language model API. 1,000 customers are hammering your servers with requests every single second. With traditional inference, each request takes, say, 200 milliseconds. With ZML's optimization, that same request might take 100 milliseconds. That's 50% faster. What does that mean in the real world? First, users get their answers faster, obviously better experience. But here's the business side. You can now serve twice as many requests on the same hardware. That translates directly to lower infrastructure costs, better profit margins, or ability to lower prices and crush competitors. A startup running AI models on tight budgets suddenly becomes viable. A company that was thinking about pulling inference work off GPUs because costs were exploding suddenly finds it's actually affordable again. Scale this across the industry, thousands of companies, billions of inference requests daily, and you're talking about hundreds of millions of dollars in recovered infrastructure costs annually. Major companies have already started integrating ZML's tools into their systems. Early adopters are seeing their model-serving costs drop while performance metrics improve. This cascades through the entire supply chain. Cloud providers like AWS and Google Cloud start offering ZML-optimized inference as a premium tier. Hardware vendors like Nvidia benefit because their GPUs suddenly look even more competitive when paired with better optimization software. And this is just the beginning. Now you might be wondering, aren't there already tools that optimize inference? Yes, there are. Nvidia has their own optimization libraries specifically for their GPUs. TensorRT is their flagship tool. AMD has similar offerings. Intel has OpenVINO. Qualcomm has their neural processing unit frameworks. The problem is they're all proprietary, vendor-specific, and don't talk to each other. If you want your model to run well on multiple chips, you need to maintain separate optimized versions for each platform. It's expensive, it's error-prone, and it fragments the ecosystem. There's also quantization, techniques that reduce model precision to make them smaller and faster. But quantization requires careful tuning per model per hardware combination. It's not a silver bullet. Some open-source alternatives exist too, like TVM or TensorFlow Lite, but they've never quite achieved ZML's depth of optimization or ease of use. Here's what makes ZML fundamentally different. It's universal, it's open, and it's getting better through community contribution. You're not locked into one company's roadmap. You're not waiting for Nvidia or AMD or Intel to prioritize your specific use case. The entire ecosystem is investing in making inference faster for everyone. It's the difference between having multiple private toll roads owned by different companies versus one open highway that everyone uses and improves together. And this is where things get complicated. Implications ripple outward in fascinating ways. For chip manufacturers, this is actually great news and a little bit threatening at the same time. Great news because better inference software makes their hardware look better. Your Nvidia GPU just got faster without a redesign. Threatening because now performance advantages aren't just about raw silicon anymore. A company with brilliant optimization software can make older hardware competitive with newer designs. For AI companies, this is fundamentally about margin preservation. OpenAI, Google, Meta, and others have been in an inference cost arms race for years. Better optimization means they can maintain profitability while lowering prices and capturing market share. Smaller startups building AI products suddenly have a chance. Their infrastructure costs plummet. For developers and engineers, this is liberation. Instead of learning NVIDIA-specific coding, AMD-specific coding, and Intel-specific coding, you learn one framework. Your models are portable. Your investment in optimization pays off across all platforms. For data center operators, inference becomes more efficient, which reduces power consumption and cooling costs, increasingly critical as AI workloads explode globally. The environmental impact is real too. More efficient inference means less electricity burned, which means less carbon emissions from data centers. At planetary scale, that's genuinely significant. But here's what's genuinely surprising about this move. You might ask, why would ZML give away their best technology for free? Won't they go out of business? Actually, this is a brilliant strategy. Open sourcing foundational infrastructure is how companies build massive influence and market position. Look at Linux, completely free and open, yet it powers the entire internet. Kubernetes, free and open, yet it's become essential infrastructure for thousands of companies. The companies that maintain these projects become indispensable. ZML maintains the core tool, provides premium support packages for enterprises, offers consulting and integration services, and gets to influence the entire AI ecosystem's direction. They're essentially letting others invest in making their product better while becoming the central hub everyone trusts. For developers using ZML's tool, it's straightforward. You download the open-source version, integrate it into your inference pipeline, and it automatically optimizes your models. For enterprise customers with complex deployments, ZML offers professional support, optimization consulting, and custom features. It's the classic open-source business model that's worked for decades. This also explains the timing. We are at an inflection point where inference optimization is becoming the competitive battleground. ZML gets there first with the best solution and makes it free, so everyone defaults to their platform. By the time proprietary competitors catch up, ZML is already entrenched as the industry standard. The best part, everyone wins. Users get faster inference, companies save money, developers use better tools, and ZML becomes fundamental infrastructure that can't be ignored. So here's what this moment means for you. If you're a developer, keep an eye on ZML. This is going to become a core tool in your infrastructure stack. If you're investing in AI infrastructure companies, watch how quickly major cloud providers integrate this. If you run your own AI models for your business, start exploring ZML's tools because lower inference costs translate to real money in your pocket. Bigger picture is that we are entering a phase where inference efficiency becomes the next arms race. After the model size wars, after the training optimization wars, now the battle changes to who can run AI code fastest and cheapest. ZML just fired the opening shot by handing everyone a free weapon. The companies that master inference in the next 12 months will have enormous competitive advantages. We're going to see this ripple through earnings reports, better margins, expanded deployments, new AI products that only work because inference became suddenly affordable. The real story isn't just that ZML released a tool, it's that the entire economics of AI deployment just shifted. That's genuinely significant. Follow at Riffs. AI. Headlines for more on how the AI infrastructure landscape keeps evolving. New analysis drops tomorrow.